Digital modes. Most of the digital modes, the FT8 and all, I think everything in that suite of software uses frequency shift keying. There's kind of two types. There's what's called direct and what's called audio frequency shift keying. I think the next chart or two talks about those. RIDI is one of the digital modes. It's not part of the weak signal suite, but it also uses FSK, and it does what they call mark and space to represent ones and zeros using two different frequencies. I forgot what they are, but there's like 700 hertz difference between them, like 1200 versus plus or minus whatever it is. Yeah. Yeah. Which of the following types of modulation is used for data emissions below 30 megahertz? Direct frequency shift keying is where you're actually sending a digital signal to change the frequency of your VFO. So you actually transmit on different frequencies depending on what the symbol is you're trying to send. In the case of audio frequency shift keying, you're operating in single sideband and your computer is generating an offset plus the modulation signal. In the case of FT8, they divided up the 50 hertz bandwidth into 8 segments to represent each phase of for the symbol, which represents three binary bits. So there's 8 stages, steps, and you modulate the VFO with that analog signal as opposed to directly doing it digitally and changing the frequency. Let's make sure you're just mix around your wild right fish. Oh, I like to listen to them. Yeah, yes. And you're hearing those 8 different tones. The problem is it's not going into radio. The trick with FT8 is setting up the computer and the threads. And also, you can operate in what they call split mode in FT8, which actually works better. And what it does, instead of doing the offset plus that little modulation, it will change your transmitter frequency. So the offset is always between 1,000 and 2,000 hertz. Whereas if you just do it normally and you went down to the bottom of the bass band, like 300 hertz, you're down there at 300 hertz with a 50 hertz signal. So your signal to noise ratio isn't nearly as good, and that's one of the reasons why split mode works better, because you keep the ratio of the modulation to the offset much higher. I think the first time I did that, and I happened to look over when it was transmitting, that's not 14074.
Yeah, it's nice to line going like, well, this is off. I mean, we're still able to make it a content. Key lock, the frequency lock, still changes. Here trumps the
yeah. What is the difference between direct FSK and audio FSK? Nothing. Okay, all the weak signals use frequency shift keying, even including whisper. Now, I will say that I agree the FT8 is the most popular digital mode. I'm surprised there isn't that much FT4. Probably, when I've looked at it, probably half the activity that you see on FT8 at the same time. It is a little faster because it's doing it in 7.5 seconds instead of 15 seconds for the transmit cycle. I don't know about their statement that there's more FT8 contacts than all our other modes combined, but I wonder if that means digital modes. I can't believe there's more FT8 contacts than there are single sideband or CW contacts.
Well, the content's still.
Oh yeah.
Once your code is done, they shut down and move to the next small CPU.
I mean, each cycle is 30 seconds, and if you're lucky, I mean, you might get through it in 3 steps.
Well, I guess just fishing out CPU juices back and forth with all the information and bursting back and port received and then
Right. But FT4, because it doesn't have as much error correction and other things in there, it can't receive to the same signal and noise levels. FT8, which we mentioned before, uses 8 tones. So each tone is 6 1/4 hertz. So they just divided 50 up by 8. So each a 0 is your 0 hertz plus the offset. And a 1 is going to be 6 1/4 hertz and so on. And they call that audio continuous phase frequency shift keying. And the transmit cycle is 15 seconds and the decode cycle is 15 seconds. So it's a 30-second cycle for every time it wants to transmit or decode. And the other thing, like they mentioned, you can set it up so you start on odd or even time slots. So a lot of times there will be people on the opposite time slot that you're not seeing. And if you switch, you might find other stations that are there you just didn't see because you're transmitting at the same time that they're transmitting. So what is the length of an FT8 transmission cycle? Like I said, it uses 8 tones, 6 1/4 hertz increments, and each one of those symbols represents an octal code, 3 bits. So it winds up with a bandwidth of approximately 50 hertz also. So except for PSK31, I think it's the narrowest of the modes. PSK31 is 31 hertz. Which of these digital modes has the narrowest bandwidth? FT4. No, they say it's becoming popular. I didn't see that much activity, but I only looked at it a few times. Did make some contacts. It's really a stripped down FT8. It's just doing a symbol representing 2 bits instead of 3. So there's only 4 tones. And is twice as fast on the transmit receive cycle. And the trade-off is it's faster, but you don't get the same kind of performance as far as signal to noise ratio. The screen looks almost the same as FT8. The only real difference is somewhere. Actually, that looks like it says FT8. It's supposed to be FT4.
Yeah, it should be.
But I don't remember it being anything different except the mode changed. And the time down here, yeah, this is definitely FT8 screen because it's showing 9 to 15 seconds on the cycle. What does 4 in FT4 refer? Some of the apps, I think the one I'm going to show doesn't. Some of the apps that do RIDI show you this liturgy pattern with cross ellipses. So that's how it's showing you that it's properly tuned in when you have equal ellipses at 90 degrees. And if one of them is bigger than the other, it means that you're off frequency. This particular one, which is MTIDI or something like that, just has this scatter kind of plot. I don't know if there's a liturgy pattern or not, or maybe it just hasn't got there. It's been a long time since I used it. I think you actually have to get kind of synced up before you see the liturgy.
Yeah, it doesn't. It comes like that, but and then come into focus, and then you'll see them kind of do the.
Okay. This one I'm not familiar with. It's a new mode called FST4. Says it's optimized for two-way QSOs, and it uses a four-tone Gaussian frequency shift modulation. And it appears kind of complicated when I looked up. There's different transmission receive sequence lengths. When there's 7 of those, along with it, there's 7 different possible tone spacings, and then there's 7 different transmit receive periods. So it really is kind of a complicated. Maybe it's simple to use. I haven't tried. Which of the following is a characteristic of FST4? I'm sure. Oh, yeah. 7?
7.
They talk about the fact that all the WSJTX modes are time synchronized. So you have to be within that same time window in order for them to decode properly. And usually one of the indicators you'll see about the signal is the time delay. And it'll start turning red when it gets up around 0.2 or 0.3 seconds. It'll still decode, but I'm not sure where the cutoff is. It gets harder and harder to decode the farther off the time base is.
6 o'clock. Gods. Well,
yeah, fortunately, you don't have to necessarily sync the radio, just the computer.
just
Which of the following synchronizes WSJTX digital mode transmit receive timing? JT65 and Q65, I guess are similar. They use JT65 for doing moon bounce. I haven't actually tried Q65, but I guess you can do it for more of the ionospheric scatter stuff, as well as Earth, Moon, Earth. Maybe it's got some advantages over JT65, I'm not sure. Oops. Trying to see, the answer is so I guess that would help getting an I don't know how many signals are averaged per unit time. I guess that would help somewhat. WSPR is weak signal propagation reporter. It's kind of like APRS, except it's specifically for weak signal reporting. And there's beacons all around the world that do WSPR. Basically, so you can check what the propagation is. So if you can, and they transmit on different frequencies, they cycle. So if you can pick up a WSPR beacon in Alaska, it says the propagation between you and Alaska is pretty good because they're very weak. And it just supplies some information, including, can include the GPS and a few other pieces of data. Which of these digital modes does not support keyboard-to-keyboard operation? An old Pactor. Now that's another one I'm surprised is still around. And it's been around a long time. I guess it was kind of one of the first packet radio things where it got its name. It also uses frequency shift keying. One of the things that's different about it, it uses the ARQ protocol for error detection, where if the message has some form of parity or checksum, and the receiving station detects an error, it sends an automatic repeat request back to the transmitting station, and it will resend the message. It's usually programmed to do it 3 or 4 times before it times out and says bye. Apparently, you can't use Pactor for keyboard to communicate, keyboard to keyboard, like doing PSK or RIDI. It just sends packets. Pack 4, which I think is the latest iteration of it, has a little higher data rate than the initial one. So it's faster than all the ones they have listed. But it's my understanding that to do Pactor, you still have to have Pactor modem. Yeah. I don't know. Would think if it's that popular, somebody would have some form of clone or computer to emulate it instead of having to buy this hardware box.
Yeah, recent very much involved. That's usually the knowledge second each.
Which of the following HF digital modes can be used to transfer binary files?
Those drivers thing. I'm sure you.
Yeah, I ran across on what that really is, and I forgot. So it only comes up as a wrong answer. Which of these digital modes has the fastest data throughput under clear communication conditions? Because if it's bad, it's going to have to keep retransmitting, so your throughput really goes down. Automatic link enable. I always thought it was establishment. They say it's link enable.
I was thinking this.
So if it's operating in ALE mode, they keep scanning this list of frequencies and will activate when it gets a call sign on one of those frequencies it's looking for, and then try to set up the link.
You have to create an area source to be able to radio password. So I'm going to for those all the time.
Like an old host file in the computer for internet, right? If you can't make the contact, some of the reasons could be that you're on the wrong frequency. Duh. You're not using the right protocol. Another duh. And let's see, what am I saying here? The other station. No, because somebody else is on that same frequency, and they can't hear you because they're hearing somebody else. So for standalone, you need a SSB radio in the HF band. With an internal microprocessor and an MFSK modem.
Frequency shifting.
I assume there's multiple frequency shift keying. I'm curious about the internal microprocessor in the radio.
It's not like it's
That's what it sounds like.
There's specific radios out.
So it's got to be an ALE radio. Okay.
Yeah.
Yes, that's why they say a standalone ALE radio.
Like there's another one. They're really Australian. They design radios for ALE. And usually they're used for knowledge and
Yeah. Okay.
stuff. That's
No, it's not just normal amateur radio stuff.
no.
ALE operate on different bands, or
Advanced relations use. But this is radio most of them that channelize is people. Because when you know the area set,
you don't want to confuse those public people.
you know so you can scan.
That's why the code plugs came into existence back when it was a hardware plug. So it already set up the radio. You can only do what they coded it to do. I still have a problem with code books. It's software now. But it's not even software. It's just a list of parameters that you load.
That's what everybody calls them code.
I know. Bugs me. Let's see. Scanning the frequencies, listening, decoding. There's a quality score on the signal based on the bit error rate. That's not a question, but it's interesting. So how do ALE stations establish contact?
Yeah.
Let's see. Oh, phase shift keying. Its one advantage is it can have very narrow bandwidth, which is why PSK 31, which is called that because it's phase shift keying and it's 31 hertz bandwidth. And one of the ways they do that is they use variable length coding so that the most commonly used characters, instead of being ASCII where everything is a fixed length, the most commonly used characters in Veracode are the shortest ones. So instead of having a fixed length code, it varies from a couple of bits up to 9 or 10, so fairly long for some of the weird stuff that you never use. And in fact, there's a table, and if you look for, let's see, lowercase e is only 2 bits. And an O, which I wouldn't have thought is quite as common, was 3. And an A is 4. And an I is 4. Where's U? Oh, not cut off. I would assume U is another one that's probably 3 or 4. So the AEIOUs are the shortest ones. And they go on up to as many as what? 9 bits? Oh, more than that. 10 bits. Which of the following HF digital modes uses variable length coding for bandwidth efficiency? Okay. You rip right through those.